Today we are going to be doing 8.7, which is factoring special cases. The big thing we are going to do is when it's a difference of squares. So our essential question is, how do you factor with no middle term? You will be learning a shortcut for these problems today. So it doesn't work for all problems, but it does for the ones you're learning today. So in order to get into what we're learning, I'm going to use the phrase perfect squares. Perfect squares are numbers you can square root and get an integer, meaning like no decimals. So if I'm looking at this list, is the number 9 a perfect square? I would say yes, it is. Sorry, I want to change that to highlighter. This one is a perfect square because you can square root 9 and you'd get 3. If you square root 8, if you put it in your calculator, you would get like 2 point something, so that doesn't work. Same thing with 5, you wouldn't get a whole number, but you can square root 36, you get 6. You can square root 4, you get 2. And you square root 25, you get 5. So that's what I mean when something is a perfect square. You would get a whole number when you square root it. So how does that help for today? So these are the types of problems you've seen. Normally there's an x squared and an x. Today's will not have a middle term. It might look like x squared minus 49. So this is a clue that you can use our perfect squares method. So for this, difference of squares is when there's no middle term. That's really important, no middle term. And it is subtracting in between. It doesn't work if it's like adding. Otherwise, you would just take out a GCF only. Here's an example of what a difference of squares problem look like. So if there is no middle term, you can think, okay, then what is it? If it isn't there at all, it must be 0. So one way to do these problems is you can put in a 0 in for x if you'd like. And then you can do the exact same thing that we've been doing all last week. So actually, if this is all you learn from today, there's no excuses for why you can't do this, because the only difference is that we are adding 0 in the middle. So it could also be 4 and 1. And then if I do negative 9, that could be 3. It's negative, multiplies to a negative, so it must be one of them is negative. Or it could also be 1, negative 9. And then I'm going to test my values here. If I test the first one, it'd be 2x plus 3 and 2x minus 3. And if I actually go through that, I'd get 4x squared minus 6x plus 6x. Minus 6x plus 6x would give me 0, so that is your answer. Okay, but really you could just go through testing just like we did all last week until you get it to get 0 in the middle. So if I do this one, I kind of already went through and listed out. I'll notice the middle is missing. X squared is just 1 and 1. And then I'm going to try these. And again, I want it to get it to equal to 0. So I'd have x plus 4, x minus 4. And if I distribute that, I would get x squared minus 4x plus 4x minus 16. Negative 4x plus 4x gives me 0. So that is my answer right there. So same thing over here. If I do my first test, on the second one, it would be x minus 11, x plus 11. You can put a 1 in front if you want. If I test that, I'd get x squared plus 11x minus 11x minus 121. And checking that, plus 11x minus 11x gives me 0. So these are both my correct answers for these ones. So my question to you, is there a pattern? If you look back here, 2x plus 3, 2x minus 3. X plus 4, x minus 4. X minus 11, x plus 11. You might have realized that they always, like, the parentheses actually match except for the plus or the minus. So if I look back here, 2x and 2x, and then 3 and 3, one was a plus, one was a minus. So, is there a shortcut for this? Yes, because otherwise we'd have to list out a lot for 36. The shortcut is to square root the first and last, or if you list out all the factors, the ones that match. So 36 would be 6 and 6. 25 is 5 and -5. And this is negative, so one of them would have to be negative. So my answer is going to be 6x plus 5 and 6x minus 5. This is a really nice shortcut to know, so you don't have to do too much work for these problems. Just square root the first, it's 6 and 6, square root 25, you get 5. And then again, you'll know that they match. One will be positive, one will be negative. So for this one, you should be able to do it in note time. 16, what multiplies together to give you 16? 4. So it'd be 4x square root 81, and you get 9. So plus 9. And then my other parentheses would be 4x minus 9. If I look over here, square root of 49 is 7. Square root of 25 is 5. So it'd be 7x plus 5, 7x minus 5. So, but if I look at this one, I'm like, I can't square root 8. It doesn't work. But don't forget, your first step is to always look for a GCF. Okay, that still applies here. So if I look at this one, 8 and 18, I can take out a 2. And then I'm left with x to the second minus 9. Now if I break that up, remember there's an invisible 1 in front of here. So remember my 2 is going to go out in front of my answer. I'm going to have 2 parentheses. When I square root 1, I get 1, so it's x and x, or 1x and 1x, however you want to write it is fine. Square root 9 would be 3, so plus 3 and minus 3. That looks a little ugly. I'm going to type it up a little bit faster. So it should be 2, x plus 3, x minus 3 would be my answer. Again, they should match, but one should be a plus and one should be a minus. Your homework is 8.7 on Schoology. For your summary, I would probably mention that if you see that it's the middle term is missing and it's subtraction, square root them both and have one parentheses be a plus and one parentheses be a minus. I should be back tomorrow, so we'll start reviewing for your test, which will be on Friday.